Modern cosmology is built on numbers we can verify with extreme precision. By measuring the cosmic microwave background and tracking the expansion of space, we have dated the birth of the universe to approximately 13.8 billion years ago. But this timeline visualization maps a problem. On the left, it shows the birth of the universe, 13.8 billion years ago. On the right, it maps the calculated formation of a subgiant star named HD 140283, or the Methuselah star. The data places its birth at 14.5 billion years ago. Astronomers arrive at that 14.5 billion figure by measuring the star's specific composition. It is extraordinarily depleted of iron and heavy elements. That scarcity means it had to form in the early universe, before generations of massive supernovae enriched the cosmos with heavier metals. A star cannot be older than the universe that contains it. If these two numbers refuse to align, then HD 140283 is not just a localized glitch. It is a signal that our foundational equations for reality are missing a critical variable. In standard galactic evolution, a strict ratio exists between a galaxy and its center. A typical central black hole accounts for a tiny 0.1% sliver of the entire galaxy's mass. But in galaxy NGC 1277, the black hole accounts for 14%. A black hole that massive should have completely devoured the galaxy that built it. Our models dictate that black holes and galaxies grow together in balance. Here, either the black hole formed first and the galaxy assembled around it, or the mechanics of how galaxies evolve are wrong. The math breaks down even further when we zoom out to the entire universe. All the ordinary matter we can see, stars, planets, and gas clouds, makes up barely 5% of reality. The rest is divided into dark matter and dark energy. Dark energy is the force actively pushing the universe apart. When physicists use quantum field theory to calculate the expected value of this energy, the result is off from our actual observations by a factor of 10 to the 120th power. The force pushing the universe apart and the invisible mass holding galaxies together operate in ways that defy our best equations. The forces dictating the largest structures in reality are entirely invisible, and they fundamentally break our mathematical understanding. In October 2017, the Pan-STARRS Observatory in Hawaii detected the first known interstellar object wandering through our solar system. Oumuamua was a dark, tumbling splinter from another star system, but its trajectory was anything but routine. As it left the solar system, it accelerated. Comets naturally speed up when they approach the sun due to outgassing, shedding a halo of vaporizing ice that provides a physical push. But Oumuamua had no tail, no coma, and shed no material as it sped up. Harvard astronomer Avi Loeb noted that this non-gravitational acceleration matches the behavior of a thin, artificial light sail. He suggested it might be a piece of alien technology. While controversial, the theory was not dismissed because the data from the object's flight offered no other explanation. Deep space is also generating repeating signals that defy our models. Fast radio bursts last only milliseconds, but contain as much energy as the sun produces in several days. While most are one-off events, some repeat in perfect, tightly clustered patterns that do not fit the behavior of any known natural source. These modern pulses echo a signal from 1977. A massive radio telescope scanned the sky and detected a 72-second transmission exactly at the hydrogen line frequency of 1420 MHz. That is the precise natural resonance of the most common element in the universe, the specific channel where astronomers have long expected to find a deliberate broadcast. We currently lack the framework to categorize these behaviors. Our science is incapable of distinguishing between bizarre natural phenomena, missing physics, or the first hints of an artificial origin. We do not even need to look deep into intergalactic space to find massive anomalies. Right here in our local cosmic neighborhood, the entire Milky Way is falling toward something we cannot see, hidden directly behind our own galaxy's dense band of dust and gas. Astronomers call it the Great Attractor. We are being pulled toward it at 1.4 million miles per hour, by a gravitational force equivalent to tens of thousands of galaxies. And then there is the cosmic scale. This temperature map of the cosmic microwave background shows the leftover radiation from the universe's first moments. But in Eridanus, there is a massive dark blue patch, a 70 microkelvin drop in temperature that models cannot explain. Spanning 1.8 billion light-years, theorists suggest this imprint is a physical bruise from our universe colliding with another reality. When standard models fail to account for a mass 10 times larger than its galaxy, or an error factor of 120 orders of magnitude, the natural reaction is frustration. Theories that took a century to build suddenly contain glaring, unexplainable gaps. But an uncooperative equation is exactly what signals a coming breakthrough. These anomalies, the impossibly old stars, the oversized black holes, and the accelerating void, are the raw data dictating the next iteration of physics. They are the points where old rules end and new ones begin.